I'm Raj. I'm a senior data scientist at Arca-Blanca. Not very much structure to my talk. I'm going to go through a few things that I think will probably be relevant in your decision when you're making to go from academia to industry, whether it be consulting, data science, just in general, really. But I'm going to start with a bit of a background to myself. So this is my path to data science and AI. But the first thing I'd probably like to say is a big caveat in this is, especially for data science, I would say there's no real well-defined path to data science. I've worked with exceptional data scientists from all different backgrounds, so I'd probably put myself somewhere in the middle in terms of numeric ability plus programming. I've worked with really great data scientists coming from all the way from the spectrum of like pure mathematics, having no programming experience at all the way to things like biology, literally working in labs, slicing mice, no programming experience, and then within 6 months of my previous job, we've trained that person up to as applicable in data science or as sellable as data science in industry as I was there. So with that in mind, this is my journey, but it's more just to give you a flavor of how to go from where you are in academia to industry. So I started off as a physicist, I guess, if I can call myself that. I did a physics undergraduate. I then moved on to a physics PhD in experimental particle physics. And then I got my first DS consulting job, and then that took me to Arca-Blanca. I think the key points that I'd want to make on this slide here is that the numbers associated with some of those things that I was doing along that journey. So in all of these stages in my life, I was making transitions, right? So I was going from a physics undergraduate, where I was doing mainly theory. There was 0% programming. I mean, there was some programming in there, but I hated it. So it's pretty much 0%. I did a bit of statistics. I think I missed out maths there because a lot of the maths that I do now, I probably got from my physics undergraduate, maybe even further back, like A level, I would say. But essentially, if we look at the numbers, this is where I can like track the kind of work that I'm doing now to like where those skills are actually acquired. And as I was building them up as I was going along, but there are very big transitions between the different stages of my career. So the undergraduate was mainly theory. I go into the physics PhD. I was doing some statistics. I was doing some programming. The programming there was C++ rather than Python, although a lot of the skills are like very transferable as you go. Just do any programming and you can probably learn Python in a week. Statistics as well, just knowing to use statistics to answer questions, which I'm sure most of you are doing in your daily lives already. That's the kind of baseline that would take you to a data science job. And we've got about 20% machine learning that I was doing there. I think that's probably the biggest difference that there was between my background before moving into data science and going into data science. I still think I was pretty good in terms of making that transition. So although I was doing things like programming statistics to answer questions with like maybe models with 10 or 20 parameters built from the ground up, going then from that to doing something like machine learning where you have 10,000 parameter models, although it's a very different sort of scale, you're kind of doing similar techniques and you can build the techniques or essentially see the transition in the techniques from the more simple models to the more complex models. You're always doing the same thing, like making sure that your model is fitting correctly, that you don't make some massive error in your data set, you're doing the same data engineering, that kind of stuff. I'll talk very briefly about getting my first job. So I think this is something that most people ask me about. I probably spent a bit too long in the transition between the experimental particle physics PhD and the first consulting job. First DS job, I mean. Lots of places, not just Arca-Blanca, will be willing to hold your hand through that transition. So you don't necessarily have to spend the 6 to 9 months learning by yourself. If you can like demonstrate your ability on the statistics programming and maybe a bit of machine learning at that level, people will hire you on maybe at the entry level position that we had. Because that's kind of what we're expecting. And you will grow very quickly into these kinds of roles. Also, don't be disheartened if you get lots of rejections. Right now, I'm seeing the other side of it, trying to interview people. Lots of Dunning-Kruger, lots of imposter syndrome. Not really much you can say other than just keep at it. But well, once you get past the first role, the doors do open up quite widely for you. In terms of making like career transitions, that's probably one of the biggest ones I've ever had to do. And DS, I think, is particularly good in that respect because the kind of work that you do, the skills that you gain are super transferable. So whether you want to stay in DS, you want to go into other things. Holly mentioned our technical support team that we have. A lot of those have DS experience in their backgrounds. So, it's not a bad thing to go into at this stage, especially if you're not super sure on if it's for you for the future. Next slide, please. Okay. So next, I'm going to give you a quick project example of how we structure our projects. So I, as a senior data scientist, I'm typically leading or in charge of the data science delivery. So I work mainly with a junior data scientist and the full consulting team. So this is the way we structure our projects. We typically go in with like high level requirements that George alluded to from like a senior exec level. Someone that says, we need to improve the amount of revenue we're getting from our customers, that kind of thing. So it's our job to take that and go into like the scoping phase where we have discussions around what data is available, what we can do with it. That quickly goes on to something like a literature review that we do. And excuse me, my mouth is getting super dry. It's hot in here. Into like a literature review where we want to have a look at what's available out there, what's been done before. Typically, the timescales that we work with are a lot more rapid than maybe what you have experienced in academia. So there is a lot of time to develop yourselves and develop models, but not necessarily when you are on a project. We need to make sure that the work we're doing has been proven on similar sorts of questions and problems. And then finally, just build and iterate, test against the client. So for this example, I can give you one from a recent project that I've done. So it was a software as a service company. So think of your subscription models, maybe your Netflix, Spotify, that kind of thing. And the challenge was that the customers were too expensive to acquire and weren't sticking around for long enough. So our job was to make sure that we could identify those customers early and really extract the most value from them that we possibly could. So the literature review actually came up with something quite interesting where we noticed that other people or other teams had had success modeling their customers as semiconductors. So just looking at the distribution of the data, they found that typically the life cycle of a customer of a subscription service is very similar to how a semiconductor may behave, where the exponential has a very big drop off early on, where if it's going to break, it breaks quickly, and then you've got an intermediate period of life, and then again your exponential takes over again, which I thought was quite interesting. I think that's everything that I wanted to say about this. Yeah. Okay. Next slide, please. Then I'm going to give you a bit of or just general chat about what it's like and thank you, Holly. The kind of questions that I should have asked more when I was making the transition. So this isn't just related to data science, although the topics that I have here are more specific to data science consulting. The biggest or best advice that I was given when I was making my transition from experimental physics to industry was think about your job holistically. And that means not just concentrating on the job that you're going to do day to day. Can I do data science? Can I understand this model? What are the bits of the job and what are the bits of my current job, my current life that I really enjoy, that allows me to prosper? And where do I want to see myself in 10 years? What do I enjoy? Should I be doing this or that more? So I think that if there's one takeaway that you want to take from me is make this list for yourselves. But this is the list that I kind of made. A lot of this came from before when I did sit down and make this list for myself. However, a few other things that I've added to this list, just that things that you are not necessarily aware of when you make that decision. There's always going to be blind spots and things that you have taken for granted in your PhD and only realize once you've left. So firstly, I'll start with the similarities that I found to academia. So firstly, I found collaboration. So this was one that I immediately knew that I wanted to do lots of. I don't really work well by myself in a room. I know this isn't everyone's PhD experience, but I really benefited from having, working with collaborators of my level, and maybe a bit higher, maybe a bit lower, learning from them. And that's something that I find happens most DS teams. So you're pretty sorted there in terms of that's something that you enjoy. Along with that, you've got community and growth. So I think Holly already alluded to things like journal clubs, which I really enjoyed from my PhD. Other like, outside of your day-to-day job, there are lots and lots of experiences that you could grow from in a DS role, just because of the amount of stuff going on around you, especially if you move to a place that has a established DS team. Thirdly, autonomy. This is another one that I did identify. So I didn't like the feeling of like ownership of my own work. And that's something that you'll get in data science from a very early stage. It's definitely something you get here at Arca-Blanca, but I'm pretty sure it's true across the board. Like you are building things, you're innovating. So if you were solving solved problems, no one would probably pay you this much in industry. So that's something that you really should consider that if you enjoy or maybe need a bit more guidance onto. Here at Arca-Blanca, I can tell you, from even at the entry level, people will give you pieces of work, and you may not be like the expert on forecasting or regression in this particular industry, but by the end of that piece of work, you will most likely be the expert on that particular piece of work, so that data set, applying that method to get to that answer. And it's really your, the DS leads or your coach's job to just make sure that they're challenging you enough in terms of making sure that you're asking the right questions of that model and that analysis, such that you can trust those conclusions that you get. Lastly, I think we already touched on hybrid working. That comes along with the autonomy. No one's really going to be on top of you 24/7 in data science role. They don't have the time. So that's something we should also really consider. Differences with academia. One thing that I wasn't aware of before was just how short the timescales are. So I came into my first job thinking, as long as the timescale is 20 years, which is like the timescale of building a big particle physics experiment, I'll be happy. That went down to 6 weeks, I think is our shortest delivery. Typically we work between, I think, 2 and 6 months, which is a nice balance. It's enough time to like do a bit of interesting stuff on the project, have a bit of space to work and be free creatively, but you also need to deliver on business timescales. That might not be true if you're working for Google and are doing data science for the sake of data science, but in most industry jobs, it's definitely there. And then finally, consulting. So consulting here should really be communication. In academia, you typically work with people of your level. The big world is a lot different to that. Not just true in data science, not just true in consulting, but you will have to be able to communicate effectively with lots of different people with lots of different baselines. So that's something you should definitely consider, and that's more so with consulting. My PhD, I think, actually looking back on it, gave me, I think, lots of help in terms of my consulting skills. But again, every PhD will have a different experience. So I'm saying PhD a lot. Masters as well, I think this applies completely to, or even lower. And then finally, why consulting? So this is why I chose consulting, actually. So I'll leave you with 3 things. Firstly, project variety. Making that big career decision, I had no idea what I wanted to do. Consulting gave me a way to just do lots and lots of projects, work on different industries, so that I wasn't necessarily pigeonholed to one. And then going back to the whole job hopping, very good transferable skills that you can take anywhere. Multidisciplinary team. Learning from your team here. For example, Arca-Blanca is a great one. I had it in my previous role. I'm pretty sure most consulting teams have lots of people that you can learn from. And then finally, the option to specialize versus generalize, always there. I know some people in consulting that have joined onto a client and stayed there for 2 years or so. Others like doing more short stints to discover what the field is like and then move on to answering the question. But it's really up to you to make consulting what you want, in my experience. But that's it.